A quote from Thomas Kochen, former NASA science director, on the launch of the James Webb Space Telescope. James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. What began hopefully turned into a debacle. James Webb shocked scientists with a crisis. Will the crisis now get worse, or will a new discovery from the James Webb Telescope end the debate in physics? The discussions about old theories, who is right or wrong, come to a temporary end. But what exactly does this mean? Have scientists really unraveled the mystery surrounding James Webb's impossible discoveries, or are we just being stalled with flimsy explanations? James Webb was supposed to bring solutions, but instead, the $11 billion project plunged cosmology into a major crisis. All parts of natural science associated with space are currently experiencing a shakeup, one of a kind we last saw in the Middle Ages with the shift to the heliocentric view of the world. Now, we may have to recognize that the foundations of our modern physics are flawed and that we have not come close to understanding what our cosmos really is. But how is this possible? Today's astrophysics, or, in other words, the science of the physical quantities and relationships in the cosmos, is based on the basic rules of physics, which essentially go back to researchers of antiquity, the Middle Ages, and, in particular, Sir Isaac Newton. The first observations of mechanics and dynamics were made in antiquity. Quantities and forces were described for the first time, and later, Newton discovered gravity, which is so important for astrophysics. We built our scientific observation of the universe on these foundations. We transferred the quantities and forces that were valid and observable on Earth to the universe, and this produced some consistent results. But then, the space we could see got bigger and bigger, and at a certain point, our known quantities no longer fit what we observed. This crisis began with a problem. Different methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble tension. While the Hubble constant indicates the expansion rate of the universe, in the summer of 2022, Webb discovered so many old and highly developed galaxies in space that doubts arose as to how the age of the universe was determined. Our cosmos can only be 13.8 billion years old if, thanks to Webb, we see galaxies that were already well-developed 200 to 300 million years after the Big Bang. According to the calculations of our physics, galaxies need billions of years to grow. In the case of the galaxies discovered by Webb, this would even mean that the time of their formation was before the Big Bang, challenging our old cosmology. According to the traditional view, the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since, and has undergone a slow process of evolution. But if matter cannot be correct, then we are at a crossroads. 1. Either we are making a mistake in assuming that our earthly physics can be applied to the entire universe. 2. Or we have so far only deciphered a small part of the physics that really exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics that exist in the cosmos should also be found on Earth. But perhaps we have overlooked forces and dimensions on our planet that we are only now noticing in the cosmos. Webb breaks all records. It's fantastic! This telescope can pick up extremely weak light signals. Webb's 18 honeycomb-shaped mirrors effortlessly detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these faint places of light visible for the first time. Thanks to revolutionary technology, we saw the light from the most distant galaxies, those formed shortly after the Big Bang, for the first time in the summer of 2022. These galaxies were a sensation and, at the same time, a bitter disappointment. Instead of baby galaxies, Webb showed perfectly developed galaxies that appeared to be several billion years old. But with an age of 13.5 or 13.6 billion years, this should never be the case. Scientists sometimes say that the objects in Webb's images are impossible or not real. But Webb can only show us the truth. Science must now admit that it has likely been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with these new truths. Some traditionalists, unwilling to face the new realities, vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, It took years before the Church admitted that the Earth was not the center of the universe, despite mounting astronomical evidence. Not much seems to have changed. Though we consider ourselves modern, the scenario is similar. Researchers who propose new ideas may no longer be imprisoned like Galileo, but they still face hostility. Imagine you have spent a lifetime researching and firmly believing in something, then suddenly you see images that contradict your beliefs. Your mind would likely rebel at first, and it would take time to accept the new truth. Some scientists adapt quickly, while others take longer. Many young, open-minded researchers are enthusiastic about Webb's discoveries. Rohan Naidu, the discoverer of the Glass Z13 galaxy, and F. Stein, who discovered Maisie's galaxy, belong to this generation. They have emphasized in interviews that we simply cannot know what will happen in astrophysics at this moment. We must wait for further measurements, studies, and, of course, Webb's latest images. Was it Hubble's fault? One of the great debates in modern cosmology concerns the Hubble constant, the rate at which the universe supposedly expands. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us, leading to the conclusion that the universe is expanding. Later, Belgian astronomer Georges Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we know from alternative methods that galaxy movement can be explained differently, yet these approaches were ignored for decades. But the more we observe the universe, the more discrepancies emerge. Scientists now hope Webb will resolve the Hubble tension by making precise measurements of galaxy distances and redshifts. Correcting errors in previous measurements could mark a turning point, ushering in a transformative paradigm shift, one that propels us into an era of advanced physics and deeper cosmic understanding. We stand at the cusp of a scientific revolution. Webb's revolutionary capabilities drive us forward, forcing us to challenge entrenched paradigms and explore new ideas. As we eagerly await more revelations from Webb, let us embrace this journey with curiosity and optimism. Each discovery inches us closer to unlocking the secrets of the cosmos.